Okay, when we talk about work done by variable forces, we would say that now we take the integration for the variable forces. Talking about the work done by the variable forces, we take integration formula, right? So work done is equals to I would say that F dot D, with it goes from the range from A to B, right? So this basically shows the work done is variable in nature, right? For instance, we have example for variable work done. For instance, there is a support and spring is connected to the support, right? It is at rest or initial position. After that, you applied a force on this on this spring, and it covers some displacement in a x direction, right? You have stretched this spring, so it covered displacement in this direction, but you know that it has stored energy gap, which is potential energy. And after, if you release the spring, it comes back to its original position, which is x. So we know that F is equals to minus kx. Now force applied and covers some displacement, which shows x is a constant, and negative sign show that displacement occurs in this direction, but it comes back to this direction, right? So this is negative, and this is basically variable force. For variable force, we use the integration formula, and the area under the force or displacement is variable work done, right? For instance, we have three axes, right? This is three axes: x-axis, y-axis, and z-axis, and these are the three variable force occurring in these three axes. For instance, this is xi cap plus yj cap plus zk cap. As same goes for red, x2 I cap plus y2 j cap plus z2 k cap, and same goes for it as well. For instance, we are taking force here generally, so it would be x I cap plus y j cap, indicate I cap, this j I cap indicating the directions, and k x y z k cap, right? And now we're gonna take the displacement. For a displacement, we could say that the work done is equals to fdr, and the displacement also take place in the three directions. So I'm writing the generally that dr I cap plus dy j cap plus dz k cap, and we know that the work done is equals to force 1 to displacement, right? So work done is equal to force, I'm writing here, so it is fxi cap plus fyj cap plus fz k cap, right? And then we are writing the displacement factor here, which is dri cap plus dyj cap plus dzk cap, and then we're gonna multiply it, and we get answer vdxi cap plus fdy j cap plus fdz cap. And since when you just break it down into chunks, you can write it something like this as well: fdx, range goes from a to b, plus then integration, which means for the variable force you can divide the work into the small chunks, and then you can write it as well, right? The next topic that we're gonna discuss here is that right, let me just discuss it. We have discussed that work done by variable forces. Now we're going to talk about, does work depend upon the frame of reference? Does work depend upon frame of reference? And the answer would probably be yes, a big yes. For instance, this is a surface, and two boys are standing here, the boy A and the boy B. This is a box, and for instance, this boy applies the force on this box, force applies and covers the displacement x, while this boy applies the force on this box and it is covers displacement dy. For this boy, A boy, the displacement is work done is equals to fx, but for the y boy, displacement is fdy. As you can see here, the displacement is different for both boys, this boy and for this boy. So we would say that the work done does depend upon the frame of reference, right? So this is basically introduction about the variable forces, and does work depend upon the frame of reference.